Okay, in this presentation, we are going to talk about legal implications of operating systems. Before that, let me introduce myself. I'm Sai Krishna, currently pursuing my data science bachelor's degree at IARE. So, what are the objectives of today's presentation? They are first, we'll introduce ourselves to the topic, that is, the operating systems. Then, we will explore the legal implications of operating systems. Introduction. An operating system is an interface between a computer user and a computer hardware. An operating system is a software that performs all the basic tasks like file management, memory management, process management, handling input and output, and controlling peripheral devices such as disk drives and printers. Generally, a computer system consists of the following components. Computer users are the users who use the overall computer system. Application software are software that are used by directly to perform different activities. This software is simple and easy to use like browsers, Word, Excel, different editors, games, etc. These are usually written in high-level languages such as Python, Java, and C++. System softwares are the software that is more complex in nature and they are nearer to computer hardware. These software are usually written in low-level languages like assembly language and includes operating systems. Computer hardware includes monitor, keyboard, CPU, disk, and memory. If we consider computer hardware is the body of the computer systems, then we can say an operating system is its soul which brings it alive, operational. We can never use a computer system if it does not have an operating system installed on it. Let's talk about the examples of operating systems. There are plenty of operating systems available in the market, which includes paid and unpaid. The following are the examples of few most operating systems. Windows. This is one of the most popular commercial operating systems developed and marketed by Microsoft. It has different versions in the market like Windows 8, 10, etc., and most of them are paid. Linux. This is a Unix-based and the most loved operating system, first released on September 17, 1991 by Linus Torvalds. Today it has ridiculous variants available like Fedora, OpenSUSE, CentOS, Ubuntu, etc. Most of them are available free of charge, though you can have their enterprise versions by paying a nominal license fee. macOS. This is again a kind of Unix operating system developed and marketed by Apple since 2001. iOS. This is mobile operating system created and developed by Apple Inc. exclusively for its mobile devices like iPhone and iPad, etc. Android. This is mobile operating system based on a modified version of the Linux kernel and other open source software designed primarily for touchscreen mobile devices such as smartphones and tablets. Some other old but popular operating systems include Solaris, VMS, OS 400, AIX, ZOX, etc. What are the functions of operating system? Well, briefly, these are the important functions: process management, input-output device management, file management, network management, main memory management, secondary storage management, security management, command integrator system, etc. So what's the history of the operating system? Operating systems have been evolving through the years. In the 1950s, computers were limited to running one program at a time, like a calculator, but later in the following decades, computer became to include more and more software programs, sometimes called libraries, that formed the basis for today's operating system. The first operating system was created by General Motors in 1956 to run a simple IBM mainframe to run on a single IBM mainframe computer. Its name was the IBM 704. IBM was the first computer manufacturer to develop operating systems and distribute them in its computers in the 1960s. There are few facts about operating system evaluation. Stanford Research Institute developed the online systems in the late 1960s, which was the first operating system that resembled the desktop operating system we use today. Microsoft bought QDOS, Quick and Dirty Operating System, in 1981, and branded it as Microsoft Operating System (MS-DOS). As of 1994, Microsoft has stopped supporting MS-DOS. Unix was developed in the mid-1960s by the Massachusetts Institute of Technology, AT&T, Bell Labs, and General Electric as a joint effort. Initially, it was named Multics, which stands for Multiplex Operating and Computing System. FreeBSD is also a popular Unix derivative originating from the BSD project at Berkeley. All modern Macintosh computers run on a modified version of FreeBSD. Windows 95 is a consumer-oriented graphical user interface-based operating system built on top of MS-DOS. It was released on August 24, 1995 by Microsoft as part of its Windows 9X family of operating systems. Solaris is a proprietary Unix operating system originally developed by Sun Microsystems in 1991. After the Sun acquisition by Oracle in 2010, it was renamed Oracle Solaris. So let's talk about the generations. The term zero generation is used to refer to the period of development of computing when Charles Babbage invented the analytical engine and later John Atansoff created a computer in 1940. The hardware component technology of this period was electronic vacuum tubes. There was no operating systems available for this generation of computers, and computer programs were written in machine language. These computers in this generation were inefficient and dependent on varying competences of the individual programmer as operators. The first generation marked the beginning of commercial computing, including the introduction of eSeekers and Macaulay UNIVAC I in early 1951, and a bit later, the IBM 701. System operations was performed with the help of expert operators and without the benefit of an operating system for a time, although programs began to be written in higher level procedure-oriented languages and thus the operator's routine expanded. Later, the monoprogram operating system was developed, which eliminated some of the human interventions in running jobs, providing programmers with a number of desirable functions. These functions still continue to operate under the control of a human operator who used to follow a number of steps to execute a program. Programming language like Fortran was developed by John W. Backus in 1956. The second generation of computer hardware was notably characterized by transistors replacing vacuum tubes as the hardware component technology. The first operating system, JMOS, was developed by the IBM Computer. JMOS were based on a single-stream batch processing system because it collects all single jobs in groups or batches and then submits the jobs to the operating system using a punch card to complete all jobs in a machine. The operating system is cleaned after completing one job and then continues to reinitiate the next job in the punch card. Researchers began to experiment with multi-programming and multiprocessing in their computer services called the timeshare system. A noteworthy example is the compatible time-sharing system developed at MIT during the early 1960s. The third generation officially began in April 1964 with IBM's announcement of its System 360 family of computers. Hardware technology began to use integrated circuits, which yielded significant advantages in both speed and economy. Operating system development continues with the introduction and widespread adoption of multiprogramming. The idea of taking full advantage of the computer data channel IO capabilities continues to develop. Another programming that led to development of personal computer in the fourth generation is the new development of mini computers with DEC PDP-1. The generation was an exciting time indeed for the development of both computer hardware and accompanying operating system. The fourth generation is characterized by appearance of the personal computing or computer and workstations. The computer technology of the third generation was replaced by very large-scale integrations. Many operating systems which we are using today, like Windows, Linux, Mac OS, etc., developed in the fourth generation. Following are some of the important functions of an operating system: memory management, processor management, device management, file management, network management, security, and control over system performance. Let's talk about the components of the operating system. There are various components of an operating system to perform well-defined tasks, though most of the operating systems differ in their structure logically they have similar components. Each component must be a well-defined portion of a system to appropriately describe the function input and output. First is process management. A process is a program or a fraction of program that is loaded in the main memory. A process needs certain resources, including CPU time, memory files, and I/O devices to accomplish its task. The process management component manages then multiplies processes running simultaneously on the operating system. The operating system is responsible for the following activities in connection with process and management: create, load, execute, and suspend, resume, and terminate process, with system among multiprocessing memory, provides communication mechanisms so that processes can communicate with each other, provide synchronization mechanism to control concurrent access to shared data to keep shared data consistent, allocate, deallocate resources properly to prevent or avoid data deadlock situations. One of the purposes of an operating system is to hide the peculiarities of a specific hardware devices from the user. Input-output device management provides an abstract level of HW devices and keeps the details from the applications to ensure proper use of devices, prevent errors, and provide users with a convenient and efficient programming environment. Following are the tasks of the input-output device management component: hide the details of HW devices, manage main memory for the devices using the cache buffer one, spooling, maintain and provide custom drivers for each device. File management is one of the most visible services of an operating system. A computer can store information in several different physical forms. Magnetic tape, disk, and some are the most common forms. A file is defined as a set of correlated information and is described by the creator of the file. Mostly files represent data, source, and objects, performs, and programs. Data files can be of any type like alphabetic, numeric, or alphanumeric. The operating system implements the abstract concept of the file by managing mass storage devices such as types and disks. Also, files are normally organized in directories to use their use. These directories may contain files and other directories and so on. The operating system is responsible for the following activities in connection with file management: file creation and deletion, directory creation and deletion, support of primitives for manipulating files and directories, mapping files onto secondary storage, file backup on stable storage media. Now talk about network management. The definition of network management is often broad as network management involves several different components. Network management is the process of managing and administering a computer network. A computer network is a collection of various types of computer connected with each other. Network management comprises fault analysis, maintaining the quality of service, provisioning of networks, and performance management. The following are the features of network management: network administration, network maintenance, network operation, network provisioning, network security, etc. Let's talk about the legal application. First, what is the difference between free and open? Linux is a wonderful product of the legal system. Its many technical attributes notwithstanding, perhaps its most significant benefit are its freedom from legal claims. While some have referred to Linux as open software, it is important to distinguish between the terms free and open. Open is most often associated with open architecture, referring to a set of hardware or software specifications that anyone may use to develop products according to those specifications. Frequently, industry or government organizations produce open architectures to try to facilitate standardization and interoperability. While open refers to right to use a set of specifications, free more narrowly refers to the right to use a single program. A free program typically comes with an unrestricted ability to use, copy, modify, and distribute the software without fear of violating the author's intellectual property. In many cases, free means that the software is in the public domain and in this sense refers to freedom from intellectual property rights. Rather than the absence of payment requirement, you may have to purchase your physical copy of the free software. The open source initiative recently blurred the distinction between these two terms by wanting the term open source to refer to software that is essentially the same as the free software, although not intended to be limited to open source code. Access to source code to an important element of open source software. Because OSI is using the term open source as a certification mark, the term free should probably be used for software that generally has the attributes of free software, serving the term open source for programs authorized by OSI to use that designation. Both free and open software are relatively new phenomena. As recently as the early 1970s, was commonly believed to be unprotected by the intellectual property laws. Prior to 1936, there was considerable doubt whether the software was a work of authorship that could qualify for protection under copyright laws. Likewise, the U.S. Patent and Trademark Office and the courts generally disapproved of software patents until 1990s. So the conclusion is, so the conclusion, let's talk about the conclusion then. There are certain legal implications on operating systems as long as they are not open source, like Linux, or don't have any threat to the security of individuals and the country. That's a basic conclusion of the legal implications of operating systems. Thanks for listening, guys. I hope the presentation is clear. Bye.